Assalamualaikum and good day. Now you are going to learn one more method under LU factorization. The third method under LU factorization is Cholesky method. Cholesky decomposition is a technique that is designed for a system where the matrix A is symmetric and positive definite. The symmetric matrix refers to the matrix with the element of Aij equal to Aj for all I not equal to J. In other words, A is equal to A transpose. Cholesky decomposition method offers computational advantage because only half of the storage and computation time are required. In Cholesky method, a symmetric matrix A is decomposed as A is equal to U transpose times U. Before this, you have learned under LU factorization method, we can write as matrix A is equal to product of matrix L, U. And then after you find what is our matrix L and U, we can set up as LD equal to B. To find solution for X, we can write as Ux equal to D. But in Cholesky method, we have A is equal to product of U transpose times U. You can see that our U transpose is the lower triangular matrix. So, we can set up as, instead of L, we can write U transpose D is equal to B. And then we can solve for X where Ux is equal to D. For this method, we just find what is matrix U. Let's say we have 3 by 3 matrix. For upper triangular matrix U, we will have U11, U22, U33. U12, U13, U23. Below the main diagonal is 0. You can see that we have two formulas. The first formula is for UII, and for the second formula is UIJ. UII, that means for I is equal to J, which is for this element U11, U22, U33, you have to use this formula. The other element which I is not equal to J, which is U12, U13 and U23, we have to use this formula. In Cholesky method, we have 3 steps. First, we decompose A such that A is equal to matrix U transpose U. Hence, we may have UT Ux equal to B. From the system of linear equation, you write into matrix form, which is Ax equal to B. Our matrix A is equal to U transpose U. Substitute into A, we will have U transpose U X equal to B. Like previous method, we let Ux equal to D. That means we substitute Ux with D. We will get U transpose D equal to B. After we get our D, we solve for Ux equal to D. Now look at this example. Solve the following equations using Cholesky factorization. First, we need to write the system of linear equation into matrix form. You can see this matrix is symmetric and positive definite. the first row of this matrix is equal to the first column of this matrix. And then for the second row of this matrix is equal to the second column of this matrix. And the third row of this matrix is equal to the third column of this matrix. Now we want to find all the elements in matrix U. For the first row, we want to find what is U11, what is U12, and what is U13. For I equal to j here, we have I is equal to j, where our I is equal to 1. So for U11, we have to use this formula. Substitute I equal to 1 into the formula, we will get U. Now our I is equal to 1. Substitute I into the formula, we will get U11 is equal to A11 minus, we have sum of from k equal to 1 to, now our I here is equal to 1. So 1 minus 1 is 0. And then we have UK, our I is 1 square. And then we have square root. Next, we can substitute the value into this formula. What is our A11? A11, we can refer to the matrix A in the first row and first column. A11 is equal to 2. So we can substitute 2. U11 is equal to 2 minus, you can see our k equal to 1 to 0. That means we don't have any element here because k equal to 1 to 0. So our U11 is equal to 2 and then square root. We will get 1.4142. And then next, U12, where I is equal to 1, our j is equal to 2. We have to use this formula. For this case, we substitute I equal to 1, j equal to 2, so that we will get U12 is equal to A12 minus sum of from k equal to 1. Our I here is equal to 1 minus 1. So here is 0. UKI, UKJ divided by UII, where I is equal to 1, we have U11. Because here is k equal to 1 to 0, we don't have this term. So it will give us U12 is equal to A12. What is A12? We have to refer to matrix A. This is our A12, which is -1. Substitute -1 into here, we will get -1 over U11 is 1.4142. So for this, we will get -0.7071. Continue with U3. In this slide, we want to find what is our U22 and U23 for the second row. Again, by using the formula, when I is equal to j equal to 2, that means we have to apply this formula. Substitute I equal to 2, we will get A to 2 is equal to A to 2. Here is minus. Okay, we have here AII minus, we have sum from K equal to 1, I minus 1. So substitute I equal to 2, we will get A to 2 minus, we have sum of K equal to 1, our I is equal to 1, minus 2, that means we have 1 here. U Ki square. What is our A to 2? Our A to 2 is equal to this element. Okay, substitute into here, we will get 2. Sorry, we have square root here. Okay, that means 2 minus, okay, for K1 equal to 1, that means we have one element, okay, which is U. K start from 1, and then our I is equal to 2, square and square root. Okay, and then is equal to 2 minus, what is our U12? U12 is equal to this value. Okay, so we can write here negative 0.07071. Okay, and then we have square here and then square root. So for this, we will get 1.2247. Okay, now we look at U23. For U23, we have to apply this formula. Substitute I equal to 2, j equal to 3. This is our I, this is our j. We will get U23 is equal to A to 3 minus sum of from K equal to 1, I is 2 minus 1 is 1, UKI is 2, UKJ is equal to 3, divided by UII, where our I is 2. So for this one, we will get U23 equal to A23. We have to refer to this element, which is negative 1. So we will get negative 1 minus sum of, here we only have one element here because K equal to 1 to 1, only 1. Where K is equal, we start with 1. So we will have U12 times U13 divided by U22. Just substitute what is our U12 and what is our U13 and what is our U22. You will get this value. And then for the third row, we have U33. That means you have to apply the formula for UII. And then substitute into matrix U, you will get this matrix. And then U transpose where the first column here, you transpose, it will become the first row here. When you transpose, it will be your first column. And then for the second row, when you transpose, you will get second column. And then for the third row, when we transpose, it will give us the third column. So from U, you will get your U transpose. After you get your matrix U and U transpose, we can set our U transpose D is equal to B. You will get your D. And then after you get your D, we can solve for X, where UX is equal to D. We will get our solution for X, which is given by this value. That's all for Cholesky method. For conclusion, LU factorization is designed so that the elimination step involves only operations on the matrix A. It is well suited with the situations where many right-hand side of vectors B need to be evaluated for a single matrix A.